This is practice problem number 4 from lesson 5, Introduction to Linear Relationships. And this problem just simply states, write an equation for a line that passes through these 2 points. And so to get an idea of how to do this, I just placed these 2 points on a graph. And so I just made a rough draft, and I'm doing this in Docere, so I can draw pretty straight lines. If you're doing this on with a pencil and paper, just use a ruler, or you don't even have to use a ruler. You just have to do something that gives you an idea of how to write that equation. So place the point 2, 5, so you go 2 units along the x-axis and 5 units along the y-axis, and place a point at 6, 7. So 6 units along the x-axis, 7 units along the y-axis. And if I extend these lines, these would be the grid lines within the graph. So if I draw a line that's perpendicular to the x-axis and a line that's perpendicular to the y-axis, this is going to be the 2, and this is going to be the 5. This is going to be the 6, and this is going to be the 7. Now notice that these units along the y-axis are not equal to the units along the x-axis. They don't have to be. Be different things, different units. So if you place the 2, the 6 is going to be about 3 times farther. So if this is 1 times, 2 times, 3 times, it looks like I placed this a little bit too far in this direction. I could place the 2 really be better placed right about there, but it doesn't have to be exact. You're just making a rough draft. And the 7 would be about half again as far past the 5. So 1/2 of 5 is 2.5. So 2/2 would be the 5, and another 3/2 would be 7.5. So that would be about up here. So 7, I'll place it down about here somewhere. Again, it doesn't have to be perfect. So let's test to see if it's a proportional relationship. If it's proportional, that means that the y value of the coordinate of the point divided by the x value is going to be equal to the same y divided by x of a different point on the line, if it's proportional. And in this case, it's not. Y divided by x is equal to 5/2 for this point, is equal to 7/6 for this point. Well, they are not equal. 2 times 3 is 6, but 5 times 3 is 15. So that 7 would have to be a 15 instead of 7 to be proportional. Now, if you're doing this on graph paper, you could see that this line doesn't go through 0, 0. And you can see it here as well, but it'd be more exact on graph paper. All right, so this is not a proportional relationship. So you're going to have to move that slope triangle to get it to be at 0, 0, to write the x values and the y values and to complete the equation. So let's draw that slope triangle. So it's right here. So these values start to show up. The length along the horizontal in the horizontal direction, you can start to see what it's going to be, and the length in the vertical direction, you can see what that's going to be. So to give it away, this length from 2 to 6 is 4 units. This length from 5 to 7 is 2 units. So it's going to be this ratio of this length, which is 2, to this length, which is 4. That's going to simplify to 1/2. So that's what we're going to figure out in a moment. And it will become that easy for you as you keep practicing these in the future. All right, to get the x's and the y's in the equation, just change the 6.67 to xy. So you're going to slide this slope triangle 2 units to the left. That's x minus 2. So this length along the horizontal direction is going to be x minus 2. You're going to also slide this slope triangle 5 units down to the x-axis. So this length in the vertical direction is going to be this y minus 5. So this y minus this 5. Or remember that this is 5 here as well. And this point is this x minus this 2. And this point here is x as well. So x minus 2 slides this over to the y-axis. All right, and if you use these values, 6 and 7, that is how you figure out what the slope is. So 6 minus 2 is equal to 4 units. This length along the horizontal direction is 4 units. The length along the vertical direction, the number of units in the vertical direction is 2 units. So 6 minus 2 is 4. So the number of units here is 4. The number of units here is 2. And so that ratio, the ratio of the number of units in the vertical direction to the number of units in the horizontal direction, is the slope. And on the left side, we're going to get those y's and x's into the equation. Well, this length in the vertical direction is y minus 5. The length in the horizontal direction is x minus 2. That ratio is equal to the slope, which is 2 to 4. And 2 to 4 simplifies to 1/2. And so in words, you can say that the length, the number of units in the vertical direction, is 1/2 times. It's half as many as the number of units in the horizontal direction. And that's true. 2 is half of 4. 1, if you simplify it, 1 is half of 2. So that makes sense. So y minus 5 is 1/2 times this length in the horizontal direction, x minus 2. So now just write the equation from that statement. Y minus 5 is equal to 1/2 x minus 2. So now we're going to simplify this. We're going to use the distributive property. Now if I have x minus 2, if I want 1/2 of that, whatever that x minus 2 is, if I take 1/2 of that, it's going to be 1/2 of this x and 1/2 of this 2. Well, y minus 5 equals 1/2 of x is 1/2 of x. And 1/2 of 2 is 1. 1/2 times 2 is equal to 1. So now we're down to y minus 5 equals 1/2 x minus 1. Well, that minus 5 is this minus 5 right here. We took this away. To get to this point, we have to add that 5 units back. To get to this y value, we have to add the 5 units back. So y is equal to, so add the 5, but you also have to add the 5 to this side. Well, if I add 5 and subtract 1, that's equal to 4. So we get y is equal to 1/2 x plus 4. And so now if you go up to the slope triangle and extend this line out, where is it going to cross this y-axis? It's going to cross at that 4 right there. And you can see that by, remember that this slope is, if I go 1 unit down, that's the vertical direction, then I have to go 2 units to the left. That's the horizontal direction. So if I go 1 unit down, 2 units to the left, I get to this y-axis at a point of 4. So this is 0, 4. Well, that makes sense. That's where this line is going to cross the y-axis. So y equals 1/2 x, so that 1/2 is the slope. So you could come up with some problems that show you that. And plus, there's a 4 unit, whatever this y-axis is, there's a 4 unit head start. So the general form of this equation is y is equal to kx, that's the original proportional relationship, plus a beginning part, plus that 4. Now this k is going to change in a little while. For those of you that know the direction that we're going, this is going to be, that k is going to change letters. But right now we can use y equals kx plus how much you're starting with in the beginning. So you're going 4 units up before you ever even start along the x-axis to get to this 4. Let's say you're filling a tank, but it already has 4 feet of water in it. And then you start filling it, so it goes to 5 feet, to 7 feet. And so this would be time along this axis. Maybe it's hours, maybe it's minutes, whatever it might be. But the point is that it's already has 4 feet of water in it if you're talking about a tank filling. All right, so this is problem number 4.